Welcome back to the YouTube channel. I'm Xavier Smith, and today I'm going to go over the rules of exponents. So, let's just start. There's a couple rules. There's one more whiteboard other than this, but I tried to give an example with all of these rules. So the first one, a of m times a of n equals a of m, a to the power m plus n. So this means if you have the same base to a power times the same base to a power, then that equals the base to the power of the first power plus the second power. So if we have 2 squared times 2 to the fourth, then we really have 2 to the power 2 plus 4 equals 2 to the sixth equals 64. Because remember, 2, 4, 8, 16, 32, 64. Then, going along the same lines, a of m divided by a of n equals a to the power m minus n. So that means a base to a power divided by that same base to a power equals that base to the power of m, our numerator power, minus n, our denominator power. So if we have 2 to the fifth divided by 2 to the third, it is equal to 2 to the power 5 minus 3, which is equal to 2 squared equals 4. And you could, yeah, that's how you do it. You could just say, well, if you want to check this, 2 to the fifth is 2, 4, 8, 16, 32, 32. And 2 to the third is 8. So 32 divided by 8 is 4. Good, checked. Here, a to the negative n power is equal to 1 over a to the n. So when the exponent is negative, flip the equation. Doesn't matter, just flip it, and then that is now positive. Well, the exponent will now be positive, and it'll just be 1 over a to the n. Our example is 5 to the negative 2 is equal to 1 over 5 squared, which is then equal to 1 over 25. Now, a to the 0th power equals 1, and a cannot be 0. Anything, a is anything but 0. Anything to the 0th power is 1. It's just a property. It's going to have to be accepted. I guess if you had like x to the 0th power, that would just kind of screw things up if it equaled 0. Yeah. Now we have a, the absolute value of a squared is equal to the absolute value of a quantity squared, which is then equal to just a squared. But you have to have a even exponent. So it has to be 2, 4, 6, 8, 10. Because if it is a 3, then here, when you're just saying it's equal to a squared, well, when it's a square, when it's an even number, it's 2, 4. So like negative 3 squared equals 9. Like it turns positive. But if you have negative 3 to the third, it is negative 27. And that's not absolute value. Absolute value will always give you a positive because it's a distance and you can't have a negative distance. So this, when it's an even power, then the absolute value of a squared equals the absolute value of a, quantity squared, is equal to a squared. Now let's move on. We have 3 more little properties, and then we're done. So ab to the power m is equal to a to the m times b to the m. Simple as that. So when you have ab and it's all, both of them are to a power m. You distribute the m into it. So 3x to the fourth is equal to 3 to the fourth, x to the fourth is equal to 81x to the fourth. All you're doing is you're distributing this power of 4. So 3 to the fourth, 81, x to the fourth is, well, x to the fourth. Now, similarly, a over b, quantity to the m, is equal to a to the m divided by b to the m. Again, you are distributing this m. When it's a quantity to a power, you are distributing the power into it. So, our example is x divided by 2, quantity cubed. Well, that is, then distribute x cubed over 2 cubed equals x cubed over 8. Our last property is a to the m, quantity to the n, is really the same thing as a to the mn. So when you have an exponent and you are putting that to another power, you multiply the powers. You multiply the exponents. So the power of m, a to the power of m to the power of n, is really a to the power m times n. So 2 to the third quantity to the quantity squared is equal to 2 to the sixth, which is equal to 64. And if we want to check this, well, 2 cubed is 8. And then 8 squared is 64. So it all checks out. Thank you very much for watching this video. I appreciate you sticking all the way through it. And leave a comment if you need any more help on exponentials. Thank you.